Welcome pre-cal students to the homework help video, page 666, numbers 1 through 21. Please get out your books and your homework, and let's see if we cannot help you with finding your mistakes. Let's take a look at numbers 1 through 7. Find the component form of the vector, then find the length of the vector. And of course, length also means magnitude. Well, I've taught you when you're given a vector that is not in component form, you take the terminal point and you subtract from it the initial point. So it's vector mn. So this is your initial point, point m, and is your terminal point, letter n. So we're going to say -3, comma, -2 minus 6, comma, -7. Well, -3 minus 6 would be -9. And then -2 minus a -7 would be 5. So there we go. You took this vector and it looked like this, -3, -2. That's your terminal point. Your initial point is 6, -7, right there. And it goes from here to here. And you picked it up and you moved it from there over to there. Okay, so this is component form. There we go. And then it says find the length. Remember how you find the length? You take the square root of, and you square the -9, and you square the +5. And then 9 squared, of course, is 81, and 5 squared, of course, is 25. And so you'd end up with the square root of 106. And that is your answer. So this is the component form of vector mn, and this is the length or magnitude. Okay, this vector right here is equivalent to this vector up here because they're both the same length, they are both going the same direction, and they both have the same slope. Okay, let's go ahead and find the component form of vector fe. Now let me see something real quick here. I'm not sure if they're trying to confuse you here. And I'm just glancing at something. So hold on one second, please. Okay, I'm not sure if they're trying to confuse you or on purpose or on accident, but notice it says vector fe. So f came first, so this is your initial point over here. Usually your initial point is written first, but either way, notice it's vector fe. F came first, so this is your initial point. E came second, so that's your terminal point. And so we take our terminal point, which is 8, comma 4, and we subtract our initial point, which is 11, comma, -2. Well, 8 minus 11 is -3, and 4 minus a -2 is 6. So there, you just wrote vector fe in component form. Now let's find the length or the magnitude. We take the -3, we square it, we take the 6, and we square it, and we take the square root of that. 3 times 3 is 9, 6 times 6 is 36, 9 plus 36 is 45. Now here's where we need to start working on simplifying our radicals. The square root of 45 can be broken down into 9 times 5. And the reason I did that is notice 9 is a perfect square. In other words, I know the square root of 9. See this 45 right here? 3 times 15 equals 45, but it would have done no good to break 45 up into 3 and 15 because you do not know the square root of 3 and you do not know the square root of 45. You want to break this number up when possible, and it's not always possible, but when possible, you want to break this number up into a number that's a perfect square, like 9. So 45 is 9 times 5. I know the square root of 9, so I take the square root of 9 and put a 3 on the outside, and I'm left over with a 5 on the inside. And so there's your magnitude, okay? 3 square root of 5 is the exact same thing as the square root of 45. And this really is the answer you need to have, okay? In pre-cal by now, you should definitely be simplifying your radicals. Number 5, we have vector KL, and so K is my initial point, L is my terminal point, so we take our terminal point, 8 comma negative 3, and we subtract our initial point, which is 4 comma negative 3. So we have 8 minus 4, which would be 4, and then we have negative 3 minus negative 3, which would be 0. So there, we have written vector KL in component form. Now let's find the length of this vector. We square the 4, we square the 0, 4 times 4 is 16, 0 times 0 is 0, 16 plus 0 is 16, and the square root of 16 is 4. So there's the length or the magnitude. All right, number 7, find the magnitude of vector u. Now think about it for a second, please, students. Would you look at this vector? Look at this vector. Is it not already written in component form? You know it is because of the arrows. You see this right here. So if it's already written in component form, which it is, in order to find the magnitude, all that we have to do is square the negative 1 and then square the 6 and then take the square root of that. So negative 1 times negative 1 is 1, 6 times 6 is 36, 36 plus 1 is 37, so the square root of 37. Now, Mr. Earhart, can we break this down? No, you cannot. There are no perfect squares that divide into 37 evenly. In fact, there's no number that divides into 37 evenly. 37 is prime. You cannot simplify that. Okay? All right, let's continue on now to numbers 9 through 21. Now, the directions for 9 through 21 state, do the indicated calculations. All right, so here are the vectors they've given to us, u, v, and w, and then here's the calculation. They want us to take u plus w. So here's u right here. Let me slide this down out of the way a little bit. They want us to take u plus w. So here's u, and here's w. So we're going to take 5 plus negative 1. And that would give me 4. And then we're going to take negative 2 plus negative 3, which would be negative 5. So there we go. You did it. We added two vectors, vector u plus vector w. Pretty simple, not too hard. Okay, number 11, we're going to take 3 times w and then minus v. Now notice after we're done doing 3w minus v, we're then going to find the magnitude. That's what these lines mean. They mean find the magnitude. So we have 3w, so 3 times w minus v. All right, here we go. 3 times this vector here would be 3 times negative 1 is negative 3. 3 times negative 3 would be negative 9. And then minus this vector here. Negative 3 minus a negative 4, that would give us a 1. And negative 9 minus 7 would give us a negative 16. Now, that's the vector, but notice there's lines around this, and that means we have to find the magnitude. So the magnitude of this vector would be, well, we square the 1 and then we square the negative 16 and we take the square root of that. Well, obviously 1 times 1 is 1, and 16 times 16 would be, what would that be? Let's see, 9616256. There we go. And then add those together and you get the square root of 257. All right? That cannot be simplified. And so that is the magnitude or the length of this vector right here. Okay? All right, moving on. Let's take a look at number 13. V minus u. Well, guys, that's not too hard. I mean, we have vector v right here. It's negative 4, 7, and then minus u, which is 5, negative 2. So here we go. Negative 4 minus 5, that would be a negative 9, and then 7 minus a negative 2 would be a positive 9. And if you're struggling at all with your sign numbers, please feel free to use a calculator. All right, so we should get out for this problem here, for number 13, negative 9, 9 for that component form, okay, of subtracting these two vectors. Okay, let's take a look at number 15. 5u minus 4v. A little more complex, but still pretty much simple, just multiplication and subtraction. So 5u, so 5 times 5 comma negative 2, there we go, and then minus 4, and then v would be negative 4 comma 7. Now 5 times this vector here would be 25 negative 10. All right, now be careful here. Personally, I like to leave the negative sign and just multiply a positive 4 through. But if you want to multiply a negative 4 through, that's fine, as long as you make this positive and then multiply a negative 4 through. Either way, you'll get the same answer. For me, I like to leave the negative sign and multiply the 4 through. So 4 times negative 4 would be negative 16, and 4 times 7 would be 28. And now we're going to subtract. 25 minus a negative 16 would be 41, and negative 10 minus 28 would be negative 38. I always lean over and check the answers to make sure we've got this right, so let me check this very quickly, and yes, that is correct. Okay, so we simply took 5 times vector u, 4 times vector v, and then subtracted the two vectors. All right, let's take a look at number 17. Now 17, it looks like we're going to take 3 times u, and then notice we have lines around that, so we're going to find the magnitude, and then minus this magnitude. So please stay with me, okay? Watch carefully what I do. I'm going to put a line and then 3 times u, and of course u is 5 comma negative 2, and then close that and then put a line. Do you see what I did? See these two lines right here and here? That's the same two lines that are right here and right here. And notice on the inside I had 3u. Well, here's my 3, and this is vector u, so 3u, okay? And then notice next it's minus, so here's my minus sign, and then lines, and then vector v, so negative 4 comma 7, okay? Now, first of all, let's go ahead and take 3 times this vector. So over here I will have vector 15 comma negative 6 minus, and then the magnitude of this vector over here. So do you see what we're going to do here? We have to find the magnitude of this vector, and we're going to get out some number. And then we're going to find the magnitude of this vector, get out some number, and then we're going to bring down this subtraction sign and subtract the two magnitudes, okay? So let's find the magnitude of this first vector right here. I'll do it off to the side right over here. It would be the square root of 15 squared plus negative 6 squared, all right? Well, if we take 15 times 15, we're going to get 225. So we have 225 plus 6 times 6, which is 36. If you add those two together, you will get 261. 261. So the magnitude of this vector here is the square root of 261. Minus, okay, over here let's find the magnitude or the length of this vector right here. So here we go, square root of negative 4 squared plus 7 squared, so the square root of 16 plus 49, and that would be the square root of 65. Now, if you try to, and I'm going to show you right now, you're like, well, Mr. Earhart, I don't know how I can reduce these radicals when I can and when I can't. I mean, how do I know I can't reduce those two radicals there? Well, let me show you, okay? Here's a list of what we call perfect squares, okay? And of course, the list of perfect squares is infinite. It goes on and on and on, but I can put a pretty good list up here, okay? So here we go. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, 13 times 13. I'll stop there. If any of these numbers divide evenly into these numbers, then you know that you can simplify the radical. But if you'll look at this list of numbers, take your calculator and try, you'll see none of these numbers divide evenly into 261. That's how you know you can't break it down. And none of these numbers divide evenly into 65, so you know you can't break it down. Now you should have learned this in Algebra 2. You should know how to subtract radicals. You cannot subtract radicals unless the inside numbers, the radicands is what they're called, unless they match. In other words, if I had 2 square root of 6 minus 4 square root of 6, notice I have square root of 6, notice I have square root of 6, so I would write square root of 6, and then the outside numbers, I would subtract those, so 2 minus 4 is negative 2, and that would be your answer. But I could only do that because I had a square root of 6 and a square root of 6. Okay, and so if you don't have matching inside numbers or matching radicands, you cannot put these two radicals together. So there's nothing you can do with this except circle it, and that's your answer. Okay, I hope that helps a little bit. Number 17, moving on to number 19. Okay, v plus u, so let's bring down our v, negative 4, 7, plus u, 5, negative 2. And if it's okay with you students, I'd like to save some time. Next, it's plus 2w. So I'm going to put a plus sign. Then let's just go ahead and multiply 2 through this vector right now to save time. So 2 times negative 1 is negative 2. And 2 times negative 3 is negative 6. So there we go. I took 2 and I multiplied it times w, and 2w gave me this vector right here. And now let's go ahead and add these up. We're adding all the way across, so we can do this pretty quickly. Negative 4 plus 5, I'll circle them for you. Negative 4 plus 5 plus negative 2. Use a calculator if you need to. You'll get out negative 1. So negative 1. Then we're going to take 7 plus negative 2 plus negative 6. And if you do that correctly, you will get a negative 1. So there's the answer. Vector right there, negative 1, negative 1. Okay? And then lastly, number 21. You should have had a question on this. If you didn't, I'm not sure if you're really doing the work. You really should have a question on this. And the question is, Mr. Earhart, what is this vector right here? Well, that's called the zero vector. I knew we'd come across it eventually. I really didn't put that into your notes because it's such an easy thing to do, to understand. But when you see this letter here, it stands for the zero vector, and it means this right here. It just simply means vector 0, 0. Okay? So in other words, it has no length, it has no magnitude, it's just a point right here, and that's the zero vector is what we call that. Okay? So do understand that from now on when you see this, it's called the zero vector, and it's just 0, 0. Okay? With that in mind, let's go ahead and first of all notice we have 2v. Well, I'm going to go ahead and just multiply the 2 through v right now. If I do that correctly, 2 times negative 4 is negative 8, and 2 times 7 is 14. Okay? And then plus, well, what's the zero vector? Well, it's 0, 0. So obviously if you add those together, you're going to get negative 8 plus 0 is negative 8, and 14 plus 0 is 14. So there we go. It's number 21. And that is basically it. So I hope this homework help video has been a help to you. Please call or email if you have any questions.